Hello friends, welcome to Susan and John MathTube. This is lesson number 9 in the examination preparation series for the first year, first part engineering students. And as always, the most important 5 things. And it's already lesson number 9, so I'm not going to read those things, but I'll be really happy if you're following all these things. Anyway, with that, let's continue properties of definite integrals. So, in the last video, I gave you a very clear idea what is definite integral. So, definite integral means continuous summation of the function values. I showed you how function heights and depth are created. So, it's basically adding all the small rectangles or the sum of the area of all those rectangles. And I proved that integration need not be area. And I again promised you one thing, integration will be the area provided the graph is a positive graph, means the graph is completely above the x-axis. And then we learned a few properties which I list now and I want you to note them. So property number 1, integral a to a f of x dx will be equal to 0. And property number 2, if you interchange the limits in a definite integral, then what will happen to the integral value? It will be negative. And the third one, integration can be split at any point and restarted at the same point. This is because of the cluster of real numbers. Because there are so many numbers between 1 and 2, even if you leave that number or take that number, it doesn't make any difference. So it will be like integral a to c plus integral c to b itself, the function value dx. Okay. I hope you are listing all these points in a paper. Now the most important thing that is especially important for your syllabus or for the examination is integral 0 to a f of x dx is the same as integral 0 to a f of a minus x dx. So we are going to do most of the problems based on this property. Anyway, in the last video we discussed 2 more properties, so I want you to note these things. So this is a to b f of a plus b minus x dx, and then we learned a very interesting property for the special case minus a to a and for even and odd functions. So we learned in the geometrical meaning of odd function, we learned that half the graph will be above and half the graph will be below. And we saw examples of sin x, x cube, and you can try many other examples. So this answer will be equal to 0 because whatever you add will be subtracted from this side. And that means the integral value from minus a to a. That is very important. It should be from the same point in the negative side to the positive side, provided the function is odd. And it will be 2 times 0 to a f of x dx, provided the function is even, because even functions are always symmetric about the y-axis. Okay, that's it. If you want to know more about these things, you can watch the previous video, lesson number 9. Now we will go for most or more important things for the exam. Okay, so I'll give you one example how to solve these problems. Okay, look at this. Evaluate the integral 0 to pi by 2 root sin x the whole divided by root sin x plus root cos x dx. Okay, so what you do is you keep in mind this property, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. You keep in mind this property and let's call this as equation number 1. Okay, now what I do is, according to this property, look at this, it looks similar, 0 to a. So 0 to pi by 2. So a is actually pi by 2. And this property tells you to replace the argument with upper limit minus x. You have to replace the argument with the upper limit minus x. So for your convenience, I will circle the argument of the function. I will circle the input variable of the function. And now what are we supposed to do? So we get root under sine and the argument will change into upper limit minus x. The whole divided by root under sine. Again, the argument should be replaced with a minus x. And in this problem, a is actually the upper limit pi by 2. Plus root under cos pi by 2 minus x. Okay, now this is something very basic. Still, there might be some students who are not that familiar with the basic things. For them, I'll write here sine 90 minus x. I guess you learned this in class 8 or 9. Yeah, sine 90 minus x is cos x. And cos 90 minus x is sin x. Okay, so you have to remember these things and we substitute. So I'll move on to the next page. So we simplify. So this becomes root cos x by root sin x plus root cos x dx. And I'm going to call it equation number 2. Actually, I skipped one step. This will become cos, this will become sin, and in between it is plus. And you're engineering students, so you know what's going to happen. I just skipped these things. Okay, now I want you to focus on equation 1 and equation 2. I want you to focus on equation 1 and equation 2. And to make you understand properly, I'll write equation 1 and 2 together. Equation 1 tells you I is equal to root sin x by root sin x plus root cos x dx. This is equation number 1. I'll show you once more. Look at this. This is our question. And then I simplified and I found equation number 2. And equation number 2 tells me I is equal to 0 to pi by 2 root cos x by root sin x plus root cos x dx. Okay, now the trick is a very simple trick. Add the integrals. Addition is possible if the limits are same. So let's go ahead, add them up. What is I plus I? 2i. And then what we do is, I think you might have learned the property. Integral f plus integral g is equal to integral of f plus g provided the limits are same. Actually, you might have used this property, the splitting property of integrals. Now I want you to think in reverse. So we are going to add the two things. So I'm going to write this integral as a common thing. And then I'll get root sin x by root sin x plus root cos x. I'm not writing that neatly, but in your exam paper, don't do this. Root sin x plus root cos x. Okay, that's it. Okay, so this is our 2i. So 2i is equal to integral 0 to pi by 2. You can see that this is common. So when we take LCM or when we take common, you're going to get root sin x plus root cos x. Look at this. If you just watch the video, you may not understand. So make sure you're working out the problems along with me. So this get cancelled. So we get 2i is equal to 0 to pi by 2 dx. That's it. So Look at this. The advantage is you're given a question and you apply the property, add the integrals and simplify. Once you do this, in most of the problems which they ask for the exam, you will be able to integrate afterwards. So that's a promise I can give you. You're given an integral, apply the property, simplify a little bit and then add the integrals. Once you add, you will get 2i is equal to something, of course an integral, and the promise is in most of the questions which they ask in your exams, after this step you will be able to integrate. Okay, what is integral dx? Yeah, so we get 2i is equal to integral dx is x within 0 to pi by 2. Now plug in the upper limit. So you get pi by 2 minus 0. Now one very important thing, we want I. I hope you remember the question. Evaluate I is equal to. So what's the value of I? Yeah, pi by 4. Okay, let's make things a little bit more perfect. So please write, evaluate the integral 0 to a root x the whole divided by root x plus root under a minus x. So shall we start? Before we start, keep in mind the property. Integral 0 to a f of x dx will be equal to integral 0 to a f of a minus x dx. That is, the property is asking us to replace x with a minus x. So I'm going to circle the argument part so that you'll have a little bit of advantage. And look at this, the limit is 0 to a. That's compulsory. It should be from 0 to a number. So there is no change in limit. Look at this, there is no change in limit. And what we do is, we replace this argument with a minus x. We replace the argument with upper limit minus x. So we end up with a minus of a minus x. Be aware of the brackets. And oh, I forgot. We have to call the given integral as equation number 1. Now I simplify, I end up with 0 to a root a minus x. I'll show you that part. Yeah, see? By, now look at this. This one, when you simplify, it will become root x plus, it's the same thing, root a minus x dx. So this is our equation number 2. Now for your advantage, I'm going to write equation 1 and 2 together. So this is equation number 1, what you call root x by root x plus root a minus x dx. Let's check out that once more and confirm it. Root x by root x plus root a minus x. Now this is equation number 2. Look at this. The denominator is same. The numerator is root a minus x. So we go and write equation number 2. 0 to a root a minus x by root x plus root a minus x dx. And that is equation number 2. Now what we do is, we are going to add equation 1 and 2. Equation 1 plus 2. I plus I, yeah, 2i is equal to, integral is common because the limits are same. So root x by root x plus root a minus x plus root a minus x by root x plus root a minus x. Once more I'll tell you, I am not writing that neatly over here. But as students, it's your job to practice very neatly. And even more important, in the examination, make sure you write the presentation. That's very important. Anyway, what's common over here? What's the denominator? Yeah, and it'll get cancelled. And you're going to get 2i is equal to integral 0 to a dx. Trust me, if you take LCM or if you do common, you're going to get this. So 2i is equal to, what is integral dx? X within the limits 0 to a, that is 2i is equal to a minus 0, that is a. But we are trying to find I, and what is I? A by 2. That's it, finished. Now let's try one more question so that your base becomes really good. So, are you ready with that question? Yeah, please write. Evaluate the integral 0 to pi by 2 log tan x. Evaluate the integral 0 to pi by 2 log tan x dx. So look at this, it's in the form 0 to some number. And what's the first thing to do? Yeah, call it equation number 1. And before we start, I think we have to discuss a few things. Point number 1, log A plus log B is equal to log of A into B. And one very important thing, in calculus, even though we write log tan x, it actually means ln tan x, that means log to the base e. In many books, they are not specifying log to the base b because they expect us to understand log being used as the natural logarithm in calculus. Okay, now point number 2, logarithm of 1 is equal to 0. And point number 3, tan 90 minus x. Again, this is from your base 6, from maybe class 8 or class 9. This is cot x. So look at this. Before we start, I want you to be very good with 1, 2 and 3 properties. So did you note these points? Yeah, I'm sure some of you know these things. But even if you know, it's better that you note these things somewhere in your notes or note copies. So shall we start? Yeah, we already started. We called it equation number 1. Now what we do is, we look at the argument. We look at the argument, and what am I supposed to do? Yeah, I have to write the limit as such. I have to write the function as such. But the argument will be changed into, oops, I didn't write that. It's pi by 2, isn't it? Yeah. So, the argument should change into upper limit minus x dx. Okay, so we end up with 0 to pi by 2. See, I told you, you should be very good with this part. What is tan 90 minus x? Yeah, that is cot x. And that's it. I'm going to call it equation number 2. This time, I'll write equation 1 and 2 so that you'll have more advantage. So equation 1 is our question. This is our equation 1, isn't it? 0 to pi by 2 log tan x dx. And equation 2 I have over here 0 to pi by 2 log cot x dx, and that is equation number 2. Now let's try 1 plus 2. 2i is equal to, integral will come common, log tan x plus log cot x. Please write neatly when you are practicing. Okay, now look at this. What is log a plus log b? Log a into b. So what happens over here is we end up with 2i equal to integral 0 to pi by 2. Look at this. Log a plus log b. Instead of a we have tan x, and instead of b we have cot x. So we get log tan x times cot x. By the way, what will be tan x into cot x? Think about it. What will be tan x into cot x? Tan x times cot x is equal to 1, isn't it? Because cot x is the reciprocal of tan x. Okay, so we get log 1 dx, and I already told you what is log 1. What is log 1? Yeah, 0. So we end up with 0 to pi by 2, 0 dx. Okay, now I'm sure some of you are confused, because so many students ask these questions when I teach in class, because some students are confused whether the answer is 0 or not. Anyway, it's a proof that question is going to be 0. So look at this. If you have integral 0 dx, the answer is constant. And if you have definite limits, then it will be equal to 0. So let's continue. So 2i equal to 0, so I equal to 0, that's it. Okay, now let's try one more problem before we conclude the video, and that will be a little bit tougher than the other ones. So let's try integral 0 to pi by 4 log 1 plus tan theta d theta. Okay, so what's the first thing to do? Let's do those things. Let's call it equation number 1. Okay, now what we do is we replace this theta with upper limit minus log 1 plus tan upper limit minus theta, because the variable is theta, not x anymore. I'm using theta over here. You can see the variable of integration here. You just read this part and you'll understand the variable of integration. So I circled that argument part. Okay. Okay, now we have a big problem. Look at this. We have tan pi by 4 minus theta. If it is tan 90 minus theta, like in the last problem, we can convert it into cot theta. But this is tan pi by 4 minus theta. And there is no property supporting this argument. Oh, wait a minute. We have tan a minus b. Okay, what is tan a minus b? Yeah, tan a minus tan b, the whole divided by 1 plus tan a into tan b, isn't it? And what is tan pi by 4? Yeah, tan 45 is 1. Tan pi by 4 means tan 45. And in case you don't have a, what do you call? And in case you don't know this, use a calculator, but make sure you use radian mode. So come on, tell me, what is tan pi by 4 minus theta? Yeah, tan pi by 4 minus tan theta, the whole divided by 1 plus tan pi by 4 into tan theta. And that simplifies to 1 minus tan theta by 1 plus tan theta, because this tan pi by 4 will become 1. Yeah, finally, we found a way, not this, but this one. Okay, so look at this. We apply that property, so we get 0 to pi by 4. Now I am going to skip a lot of steps because I already showed you what happens here. What is tan pi by 4 minus theta? Tan pi by 4 minus tan theta by 1 plus tan pi by 4 tan theta. And tan pi by 4 is 1. So we end up with 1 minus tan theta, the whole divided by 1 plus tan theta. So this is 1 plus 1 minus tan theta, the whole divided by 1 plus tan theta. And now you can take LCM. So we get I is equal to 0 to pi by 4 log, look at this, if you take LCM, we end up with 1 plus tan theta plus 1 minus tan theta, the whole divided by 1 plus tan theta d theta. And that is I is equal to 0 to pi by 4 log 2 by 1 plus tan theta. And let's call this as equation number 2. So look at this. We have equation number 1 over here, and we simplified this and we got equation number 2. And as always, for your advantage, I will write 0 to pi by 4 This is our question and this is equation number 1. And this is equation number 2. So 0 to pi by 4 log 2 by 1 plus tan theta d theta. Now what we do is a very simple thing. We are going to add them up. Equation 1 plus 2. I plus I, that is 2i, and the 0 to pi by 4 is common. Okay, now tell me please, what is log a plus log b? Because we are going to get log 1 plus tan theta plus log 2 by 1 plus tan theta. In the last problem also we use the same property. So tell me what is log a plus log b, because I am able to see log a plus log b here. Yeah, that is log of a times b. So in the next step, what happens is 2i is equal to integral 0 to pi by 4, because it's a common limit over here. I think I wrote pi by 2, please correct it, it's pi by 4. Yeah. And here we get 1 plus tan theta times 2 by 1 plus tan theta. Why do we get this thing? Because log a plus log b is log a into b. I think you're okay with this part. That is 2i is equal to integral 0 to pi by 4 log 2 d theta. Log 2 is not a standard value. So it's just a constant. Log 2 is a number, it's a constant. So we get 2i is equal to log 2 times integral 0 to pi by 4 d theta. I just took the constant outside the integral symbol. And 2i is equal to log 2. And integral d theta is theta within the limits 0 to pi by 4. So we get 2i is equal to log 2, and this will become pi by 4 minus 0, that is pi by 4. And that gives you 2i equal to, I'll write pi by 4 log 2. It's the same thing because a into b is b into a. And that gives us the answer, I is equal to pi by 8 log 2. So that's it. I'm going to stop the video right now, but I'll be back with more problems based on properties of definite integrals. And I hope you're able to understand how to apply the symbol property and solve these problems. Okay, so I'll be back with more problems in the next video. So till then, bye.